Hey guys, we're starting a new unit today. We're talking about systems of linear equations. So we're still talking about linear equations. We're just talking about systems of them. And we're going to talk about what a system of linear equations looks like. So today's goal, writing a system of equations from a graph. To do that, we're going to need to know how to find slopes and y-intercepts from graphs. So just straight from linear equations on graphs, from lines on graphs, can we find the slope and y-intercept? And then write the equation in slope-intercept form. And then we're going to also work on converting to standard form and identify the solution to a system of equations. So really, the only new thing is this last one, identifying the solution. And it's something you've actually been familiar with potentially from middle school. So identifying the slope and y-intercept and writing it in slope-intercept form and then converting. All things that you should be familiar with from Unit 3. We're just going to do it now with, if you saw kind of below, two equations. So a system of equations is a set of two or more functions or lines on a graph. And we're going to deal with really only two lines on a graph at one time. Okay, but that is what a system of equations is. It's two or more lines on a graph. So when we're writing the equations, you just have to write two different equations, one for each line. And then when we're converting, you're just converting two different slope-intercept forms to standard forms. So let's talk about solutions first. So solutions to system of equations are where the lines cross, where they intersect. You might want to write that point down, where they intersect. So if that's what a solution is, then let's look at these three types that we could potentially have. This far left on the far graph, I'm going to label it just number 1. That way I can kind of talk about it. This graph on the far left has two lines on it, a red and a purple. And they're never touching. Those are actually parallel lines. Their lines are never going to cross. So that has no solutions. That system has no solution because those lines are never going to cross. The second type of solution we might see is on graph number 2, where you have a specific point where the lines cross. Now we say that solution is at the actual point where they intersect. So if we find the ordered pair, that is going to be the solution. So one solution, right, where they cross. And that one solution is at -2, 1. And one solution is going to be your most common type of solution, but it's where the two lines intersect and it's at that point. Sometimes you'll be asked to just identify the x value or just the y value of the solution, but know that the solution is at that point where they cross. Okay, and then our third type is where you might see two lines on top of each other. That's what those double arrows that are right there, they kind of mean that there is a line on top of the other one. You can't see the red one. But this is infinite solutions because at every single point on one line, there's a point on the other line as well. So that's infinite solutions. Now again, one solution is going to be your most common, but every once in a while you'll see no solution, definitely more frequently than you would see infinite solutions. So it's important to recognize these three types, but realize that, hey, we're going to be spending most of our time dealing with one solution. We're looking for that point of intersection or where the lines cross. So now that we know what types of solutions we have, hopefully we can work to identify them, like our success criteria says. Let's work a little bit more now on making sure we can identify slopes and convert. So in example number 1, we're asked to write a system of equations for the graphs below and then identify the solution to the system. So here I see two lines on the graph, a red one and a green one. Normally your lines will be labeled for you. It won't just be equation 1, equation 2 on the side. It'll give you names for them. or kind of tell you the situation. In this case, they're not, so I'm going to label them for us. I'm going to make this one be equation number 1, and then the green one is going to be equation 2. This is just going to help us when we are writing the equations down. So, again, to write an equation, we need an m and a b. All right, we're looking for the slope and the y-intercept. So let's do that for the first line, that line in red. So first, I need to identify 2 points on the line. I see one here, and I'm going to label the other one. So I found 2 points. I'm counting my rise over run. I see that we go up 5 and over 1, 2, 3. I notice that from left to right, my graph is moving up. It's increasing, so that's going to give me a positive slope. So my first equation is y equals 5/3 x, and then the y-intercept is at positive 6. That was actually one of my points. And we're done with equation 1 right now. Now let's focus on the second one. Let's focus on that green one, that equation number 2. Again, I want to start by identifying 2 points. So I found 2 points. I can see that this one's also increasing, so it's going to be a positive slope. It's going up 1 and over just 2. So that means I'm going to have a slope of rise over run 1/2, 1 over 2x. And then my y-intercept is -1, so it will say -1. There you go, guys. That's how to write the equations. Now, to identify the solution, well, where do those 2 lines intersect? Put a point at it and find the coordinates. -6, -4. That is the solution. Okay, so it is that easy to writing systems of equations. It's just you're doing or writing the line in y equals mx plus b for both lines. So it's just a little bit of a longer problem because you have to do writing equations twice. Okay, now from there, we're going to convert those into standard form, and we're going to convert them the exact same way that we converted slope-intercept form to standard form. Your a value can't be negative, and it can't be a fraction. Let's get started. So focusing on equation 1 first, we know that we can't have a fraction in front of the x. And since my slope is a fraction, I'm going to multiply by the denominator so that I can eliminate that fraction. That means I'm multiplying everything by the denominator 3. This includes the y, the 5/3 x, and the 6. Remember I pointed out to you guys that that's the biggest thing I see people missing is they're not multiplying it times that third term. Make sure you multiply the 3 by everything. That leaves us with 3y equals 5x plus 18. From there, we need to move the x and y onto the same side of the equation. So I'm going to subtract 5x from both sides of the equation, which leaves me with -5x plus 3y equals 18. Now we have a negative a value. We can't have a negative a value. So I'm going to multiply everything by -1. -1 times -5 is 5x. -1 times positive 3y is -3y. And -1 times 18 is -18. Essentially, it just changes the signs of all of them. But there it is in standard form. The first equation written in standard form. ax plus by equals c. Now let's try equation 2. Same thing, we can't have any fractions, so we're going to go ahead and start off by multiplying by the denominator. So I'm going to multiply everything by 2. We're going to end up with 2y equals 1x. And I'm going to go ahead and write the 1x for now, just to kind of have some clarity. And then 2 times -1 is -2. Don't forget to multiply times that value at the end. Now we need to put our x and y on the same side, so I'm going to subtract 1x from both sides. When I do that, I'm left with -1x plus 2y equals -2. Once again, I have a negative a value, that -1x. So I'm going to multiply by -1, everything by -1. which is going to leave me with a positive 1x, or we could just write x, minus 2y equals a positive 2. And when I go ahead and write that in my little box over here, I'm actually just going to leave that as x minus 2, y equals 2. So there it is, the system of equations written in standard form. It's important that we write and know how to write systems of equations in both slope-intercept form, y equals mx plus b, and standard form, ax plus by equals c, because you will see questions asked and systems of equations written in both forms. So it's super important that we continue to practice this skill of converting from slope-intercept to standard form. Okay, that's pretty much it for day 1, guys. For the start of this lesson, we'll finish that next part, example 2, when I see you guys in class on Wednesday. But for now, practice that 4.1, identifying solutions, writing equations, and then converting some as well. Make sure you pay attention when you're asked to convert. You're not asked to convert on every single one. Good luck. Let your sub know if you have any questions, and let me know as well.